India has launched missions to the Moon and Mars. It is building one of the world's largest space programs. Yet for more than 3 decades, one of the most difficult engineering challenges in aerospace has remained unresolved, building a modern fighter jet engine. And the story of how India is trying to solve this through the Kaveri program, DRDO's long-term research effort and new next-generation projects is one of the most complex technology journeys in the country's history. In modern air power, the engine is everything. It determines how fast an aircraft can fly, how high it can climb, how far it can strike, how much it can carry, and how well it can survive. Without independent control over engine tech, even advanced fighter programs remain strategically dependent on foreign suppliers. That is why jet engine tech remains among the most restricted in the world. Inside a fighter jet engine, temperatures exceed 1,500 degrees Celsius. Turbine blades rotate at tens of thousands of revolutions per minute. Components must survive enormous pressure, vibration, and stress for thousands of flight hours. This demands mastery over high-temperature metallurgy, single-crystal turbine blade manufacturing, advanced cooling systems, precision casting, and complex digital engine control software. Only a small group of nations have achieved this at scale. India set out to join that group in the late 1980s. In 1989, DRDO's gas turbine research establishment launched the Kaveri jet engine program. Its goal was to produce a fully indigenous turbofan engine for the light combat aircraft, later named Tejas. Over the years, Kaveri encountered major technical challenges, particularly in achieving the required thrust-to-weight ratio, meeting performance targets, and developing advanced materials and manufacturing processes. As a result, Kaveri did not reach operational deployment on the Tejas fighter. However, the program was not abandoned. It produced India's first deep expertise in hot section materials, combustion science, afterburner technology, and digital engine control systems. This knowledge now underpins India's current engine efforts as India continues active development of indigenous engine technology. Kaveri derivatives, including a non-afterburning dry variant, are being adapted for unmanned aircraft applications. At the same time, DRDO and the Indian government are pursuing a new generation high-thrust engine program for future fighter aircraft, alongside strategic international collaborations to accelerate development while expanding domestic manufacturing and design capability. India does not yet field an indigenous engine on operational fighter jets, but the technological base, industrial capacity, and research depth required for such engines are now substantially stronger than when the Kaveri program began. Why this matter? Jet engine development drives progress across materials science, precision manufacturing, advanced computing, and industrial engineering. These capabilities spill over into civilian aviation, space, power generation, and advanced manufacturing. In that sense, jet engines are not just weapons technology. They are industrial engines of national capability. India's pursuit of an indigenous fighter jet engine has been slow, difficult, and often misunderstood. But it represents one of the most demanding technological goals any nation can attempt. And for the first time, India is no longer building from scratch. It is building from experience.